What are isotopes? If you look at the periodic table, you will notice the atomic mass is rarely a whole number. If the number of protons and the number of neutrons comprise the mass, and these are whole particles, not fractions of particles, why are the masses not whole numbers? Through experiments, we have found that in nature, an element often has more than one mass. Thus, the mass on the periodic table is the average mass of naturally occurring atoms of an element. Atoms with the same atomic number or Z, but have different masses are isotopes. Remember that the identity of an element comes from the atomic number, or the number of protons. So let's look at hydrogen. Hydrogen has one proton and it has a mass of 1. So it has one proton and no neutrons. This is called protium. It's the form of hydrogen we most often talk about. But there is another form of hydrogen, so it has atomic number 1, but has a mass of 2. This has one proton and one neutron, and we often call it deuterium. Hydrogen has a third form that's commonly found, hydrogen with a mass of 3, but its atomic number is still 1. It's got one proton plus 2 neutrons, and it's called tritium. This is common among elements, and it is in nature. We don't create this, nature does. This particular table is in your book. It shows you the element, the symbol, the atomic number, the number of protons, number of neutrons, the exact mass of each atom, which is a little bit off because of some things we don't talk about yet, and the natural abundance of each element. And we can use this to find the average atomic mass. Let's look at boron. Boron has 2 common isotopes, boron 10 and boron 11. We can actually use this information, the atomic mass and the percentages, to determine the average mass of a boron atom. So how do we do this? We're going to come down here. So we've got boron 10, and it has a natural abundance of 19.9%. So that tells us it's 0.199 is the fractional amount. And boron 11 has a natural abundance of 80.1%. So that would be, the fractional amount would be 0.801. So we're going to multiply the fractional amount, the average mass, will equal the fraction times the mass of that fraction. And if you look at the table up above, the mass of 10 is 10.0129 AMU plus 0.801 times the mass of boron 11, which is 11.0093 AMU. That's going to equal 1.99 AMU plus 8.82 AMU, which equals 10.81 AMU. And that's the number on most periodic tables or tables of elements, the average mass. So you should be able to use this table of abundances and be able to calculate the average mass of any element.